Hi there, thanks for joining me. My name is Anthony Turnen and I'm one of the configuration and commissioning engineers at Lawo. I specialize in VSM and many people know me as the VSM guy. I'll be teaching you how to apply GPIO logic in VSM Studio. Let's get started. Since you've probably seen this before, I'm going to speed things up a little. To start, we'll launch VSM Studio and create a new configuration with a single layer called video. Then we need a number of sources and we'll create 4 of them called CCU1 to 4. And we'll create 4 targets called monitor 1 to 4. Devices like color correctors or frame synchronizers are connected on both ends and we'll create 4 of these called processors. These are often also referred to as through devices. All configurations need a disconnect source. This one has the option is blind source checked in the attributes tab. Virtual signals are not connected to any physical inputs or outputs and they're identified by selecting is virtual signal path. You can easily identify these as they show up in yellow on your matrix. As our main tally source in most configurations is a video mixer, we'll create 4 targets feeding mixers input 1 to mixer input 4. And because mixers sometimes fail, we'll foresee an emergency embedder. These signals are now placed neatly onto the primary virtual matrix to create a nice overview. Now might also be a good time to save our configuration. Let's give it a relevant name, maybe GPIO. Now all we need to do is create a dummy connection so that we can simulate routing. When this is done, we connect every target to the disconnect source. Until now, nothing has had anything to do with GPIO, so let's start with that, shall we? General purpose interface inputs and outputs have been abbreviated to GPI and GPO. Originally, these were intended to be an interface to a physical world with physical contact closures entering the system through optocouplers or exiting through physical relays, but because VSM is a virtual studio manager, a lot of internal processing can be done without ever leaving the system. To open the GPIO window, click on the icon that looks like a traffic light that's fallen over. When you have this window open, you can also click on the menu item Window and open a second instance. I'll use the built-in Windows functionality to have GPI on the left of screen and GPO on the right. Let's create 4 physical GPI inputs. So if I have the GPIs tab open, I can right click and I can give it a name. And I can also use an iterator as used in VSM Studio, and that would create 4 physical GPI inputs at the same time. If I want to create GPI outputs, I would select the GPIOs tab and do the same thing. Right click, new GPIO. Okay, that has created 4 at the same time. You can also see that on the right hand side in the other window these have appeared. If you want to keep things tidy, it's always a nice idea to go into the config and create additional columns. I will create this one called physical. And now I have a new tab called physical. There's nothing in there right now. So I'm able to drag my GPIs by selecting them into physical and also my GPIOs into physical. And now you can see that in the physical tab I can see all of my ins and outs. I can order them by number or by their names. Note that the newly made tab didn't appear on the right hand side. This is just because of a redraw that is necessary, so I can close this window and then reopen it again. Select GPIOs and move it to the top right of screen. To show what we can do with GPI inputs and outputs, I'll quickly create a panel and I'll also show the primary virtual matrix in the bottom left of my screen. I'll also open an instance of VSM panel so that we can test as we go along. Now that we have this, let's have a look at GPI and GPIO behavior when they're used in a panel. For software and hardware panels, this behavior will be the same, except that in software panels, you'd be able to select different styles and colors, but I won't be doing any of that now. I've dragged the GPIs to the top row and the GPIOs to the bottom row. What's important to remember is that GPIs can't be manipulated from within VSM Studio. They're listeners, so they only display incoming statuses. It's not possible to change their state from a panel. For testing purposes, however, you're able to right-click on the GPI and select manual set or manual pulse so that you can see what effects this GPI would have should it be triggered from an outside event. GPIOs, on the other hand, will change color. Depending on the state of the GPIO, their state can also be changed by pushing the buttons. It's also possible to have a secondary function, for instance on a generic button, so that you can toggle the state or even create a 500 millisecond pulse. Now let's have a look at one of the most important functions of GPIs in VSM Studio, and that would be signal tally. The most commonly used tallies would be on-air or in-use signaling, and this is typically indicated by a red light or a red tally signal. This signal would need to originate somewhere. More often than not, that would be at a video mixer, and would need to be forwarded through the system. For instance, cameras need to receive a signal to avoid whip pans on air, monitors get the signal to alert the production team which signals are on air, and possibly audio mixers would need a GPIO from the system so that they could trigger automated audio follows video. Don't forget to save often, it can help you to stay out of trouble. I've quickly created the signals mentioned before, so let's apply these to our signal paths. They're visible on screen already. We'll use a drag and drop workflow to drag the red tally signal GPI from the mixer to the targets that are associated with these. The handiest workspace to do so would be the primary virtual matrix, and you need to select the GPI tab to do so. It's possible to grab multiple GPIs at the same time by selecting the first one with your mouse and then hold Ctrl to select them one by one should they not be in chronological order. Or if they are, select the first one, hold down the Shift key and select the last one. As the GPI is the tally source, we will always drag from our source to our target. In other words, from the incoming GPI to the signal path. In this case, I will select the mixer. You'll see a clipboard with all the GPIs on your tooltip, and it's important to be sure that you know where you wish to drop them. Don't just drop them anywhere, because this could land you in a world of trouble. If the window where you wish to drop them is hidden or not open, drop them anywhere where you see a forbidden sign. If you forgot to select the GPI tab, you can still do so. Simply hover over the tab until it pops to the front. You'll notice that every time you drop a GPI onto a target signal by pressing the Alt button on your keyboard without releasing the mouse button, a little icon that looks like a red sun appears. This indicates that the target is a potential tally source. If you accidentally dropped into the wrong signal path, like I just did, the little red sun mentioned before can also help you to find the mistake that you made. If you double-click on the signal path and open its properties, you can select the Tally tab, and here you'll see which GPI was accidentally dropped here. Just select Cancel to close the Properties window without making any changes, and now you can double-click on the GPI in question, open its Edit window, and then delete the attachment by using right-click and select Delete. So let's quickly test what we've just done, remembering that incoming GPIs can only be tested by right-clicking and selecting Manual Set in the GPI tab. Also remember to select the Current tab in the matrix so that we can see the signal routing. I'm manually setting GPI number 1, and immediately I can see that the little sun icon at mixer input 1 in the matrix has changed to become a little light with a cable below it. This potential tally source has now become an active tally source. Following the source that's routed to it, currently the disconnect source, forwards this tally to the disconnect source and in turn to every single destination that has currently got the blind source routed to it. I would call this undesired behavior. A disconnect source shouldn't receive tally and shouldn't forward it on. Ideally, we'd like to ensure that the disconnect source ignores the tally, and this is done by double-clicking the signal path and selecting the Tally tab. Here you see green arrows indicating if a source should receive tally and if it should also forward this tally on to other destinations. You can click on the arrow and it will become an empty arrow outline. Now you should see that the other targets that are disconnected no longer have the red tally indication. I am going to set a one-to-one relationship in the router now so that camera 1 uses CCU1 and all others keep counting. I'm also going to route my 4 cameras to my mixer inputs. Next, I'm going to use a drag and drop workflow and drag the signal paths that are CCUs to the GPIOs that provide tally to these CCUs, either by physical contact closure or by an external power supply or even by protocol if the CCUs support it. This workflow could also use the multi-select and drop with the Alt buttons, just like before. If I double-click on a GPIO, this will open the Edit window of that particular GPIO, and I can see that the signal path red tally will activate this GPIO. VSM Studio will always default to red tally first. Now you can see that as I activate different tallies, the tally information is routed through the system, ensuring that the right destinations receive their desired tally. I will now insert the processors between the CCUs and physical cameras and also route the cameras to the monitors. Let's trace the red tally through the system. Even though this is a very small system, the logic is similar, even for huge systems, provided they have a router-centric workflow. Imagine a red tally from mixer input 2. I will set this into a true state. You can see that mixer input 2 now has a red tally and forwards it to its source, which in this case is virtual camera 2. Virtual camera 2 as a source has processor number 2. So you can see that processor number 2 also has a red light. And processor number 2 in turn has CCU number 2, which in turn also has a red light. Over here you can see there is a red tally to CCU2. It's a little bit confusing because it is a green light here, but this is an active state and not a color. You can see that it's actually becoming active because it is told that when CCU2 has a red tally, it should become active. You're also able to select different colors by clicking on this light bulb. We'll have a look at that if we do preview or ISO tally. Before we continue, it may be a good idea to hit that save button. Next, I'd like to show you a very common issue and how you can use the matrix to trace it and find the reason. I'll remove the processes from the signal chain and then I'll set the red tally to mixer in 1 to true. This should trigger red tally on the chain mixer in 1, camera 1, CCU1. To make it even clearer, I'll add an automatic visual link on my panel and add mixer input 1 as the automatic target. Note that processor 1 also has a red tally, even though it isn't on air. You can see the icon at processor 1, a circle that is half white and half red. This is because virtual camera 1 is still routed to processor 1, so the signal routed to the processor is live even though the processor itself is not. There are multiple convoluted ways to avoid this, but best practice is to route your disconnect source or blind source to your unused processor. This is also a handy and necessary workflow if you ever intend to use pooling at a later stage. Now let's have a look at different tally source signals. The most common tallies, other than red to indicate that the signal is being used live on air, would be green to indicate that the signal is in preview or next, but this doesn't have to be green. It's just that most cameras only have green and red tallies in the viewfinders. You can also see that tallies are used for much more than just lights in cameras. For isolated tally, for instance when a camera is being recorded or it's a source of a giant screen in a stadium, an additional tally is often required. For this we generally use yellow tally, but not all cameras have the possibility of indicating this third layer and not everybody uses them. Let's have a look at it anyway. I've created green tally GPIs, which are the sources from my video mixer, and an ISO GPIO to show that a signal is being recorded. I'll add the ISO tally that I've just created to my panel. You might have noticed the sometimes annoying properties button that keeps popping up, and when you close it, it keeps popping up again every time you select a different button. Best is to move it to somewhere in your screen where it's out of your way. If you close it, you might end up needing it and then you can't find it. I've also created a signal path which would be a routed target that feeds our ISO recorder. The same would apply for outputs that feed a big screen. I need to add the ISO recorder that I've just created onto my primary virtual matrix. Remember that you can just hover over the Layouts tab and then it will come to the front. And if you want to put your signal between others, that can also be done by holding down the Shift button before dropping. I'll drag my ISO tally onto my ISO recorder signal path, but note that you're not allowed to drop it because I'm not in the GPIs tab. So hovering over the GPIs tab will bring it to the front, and now I'd be able to drop the GPIO that I've created onto the ISO recorder. Have a look that it's actually indicating in red, indicating that if I set it to true, it is an active red tally source. We don't want that. What we need to do is change that to be yellow. So I would double click on the tally, and then in this little icon here, I would drop down and change to yellow. Note that I only hovered now and did not click. When I set it to true now, you will see that it has become an active red tally source. Remember that the ISO tally was yellow, so we'd like to make it a yellow tally source. To do that, I would double click on the signal, and then from the drop down here, select yellow instead of red. But now we might have caused another problem, because remember that I manually set the GPI, and for that reason I've never actually unset the red. So now when I close this window or minimize it, you'll see that there's a potential yellow tally, but still an active red. This is because we've never actually told the red not to be active. This is a very common mistake many people make, and it's best to know that it can exist. So what we need to do is go back to red, and make sure that when you change the color, the GPIO is never in an active state. We'll set it to clear, double click, and then I will say that this is a potential yellow tally. Now when I set this tally, you will see that we have an active yellow tally, and any signal that is routed to this destination will now receive a yellow tally from the system. Note that when a signal has red and yellow tally, both will be indicated, but red always has a higher priority than yellow. I'll set the red tally from mixer in to false now, and then I have my green tallies from the mixer in. I can select all of them and go to the GPI tab, and by using the Alt workflow that we by now are familiar with, now when we receive a preview signal from the mixer, you will see that the signal that is in preview also gets a green tally. I've also added the ISO tally to my panel. So I can actually turn it off when we are not in record mode and turn it on again when we are in record mode. This could be done by pressing a button by one of the operators, or it could even be automated when a machine is in record mode. Most facilities have an emergency scenario designed specifically for when your mixer should fail. Hopefully that doesn't happen, but it's best to be prepared, and that is why we have one which can be achieved in many ways. But let's say that we have a routable emergency embedder that I already created earlier in this video. What I didn't create was a program output from my mixer. I'll create that now and move it to the primary virtual matrix. Now I'll save my configuration with a new name. I'm going to add emergency to the end of the current name. Next, I'm also going to create a GPIO with the name emergency. Remember that because we want to be able to change the state from within VSM Studio, I can't use a GPI, but I have to use a GPIO instead. I would like this state to be automatically activated should anything but the mixer program be routed to the emergency embedder. To do this, I will be using the emergency GPIO to monitor the crosspoint where mixer program meets emergency embedder. This is also sometimes called a node. I need to select the GPI tab in the matrix and drag this node to the emergency GPIO. If you look at the edit window of the emergency GPIO, you'll see a little logic matrix. If the node that you used is anywhere in the primary virtual matrix, you will find exactly which source and target on the left-hand side. This corresponds to the T and S that you see in the bottom right-hand corner of the matrix when you hover over the node. On the right-hand side, you'll see the unique identifiers. This is always shown as target, then two smaller than symbols, and then the source. If you ever need to remove any of these lines, simply right-click on them and select delete, or press Shift and Delete simultaneously on your keyboard. We're not designing circuit boards, so there are no logic AND gates or OR gates, but the functionality is very much the same. The basic principle is that if you can trace a clear path through the logic matrix, you will activate the GPIO. Remember that this workflow works only with GPIOs. On the left, you have the incoming GPI, GPIO, or a mix of the two. In this case, the GPI which we have picked up from the node. On the left-hand side, you'll see that as I change the crosspoint, the status of the GPIO toggles between true and false. To the right of this, there is an area where you can fill in a delay for the leading or trailing edge. If I set the delay high edge value to 1000 milliseconds, my resulting GPIO will become active exactly 1 second after the crosspoint has been set. Changing the low edge value will set the time it takes to become false again once the program from the mixer has been routed to the embedder. You will also notice the little triangle with a line at the top and the bottom. Here you can choose if a true state or a false state will activate the source. Clicking on the top line will activate when true, whereas clicking on the bottom line will activate when false. You can't select both. A dot will appear to indicate which has been selected. While we're in emergency state, the video mixer might still be triggering tally states, which in this case are a false indication of what is actually on air. To combat that, we need to disable the red tally signals that are coming from the mixer while we're in emergency mode. I'll delete the direct triggers that I created earlier so that we can adapt to the newer workflow. The most common way to manage emergency scenarios is to create a GPIO for every red tally signal from the mixer and drag the mixer red tally GPIs into the corresponding GPIOs. Depending on the native language of the system, the customer or the installation engineer, you'll find that these names are sometimes evaluation, check, or calculate. I use calculate, and I've created one for every input. Note that when a GPIO is triggered by a GPI, the little icon beside it changes to indicate that this GPIO is triggered externally. For every one of these, I also need to add that they should not activate when I'm not in emergency mode, so I will drag my emergency GPIO to them too. Now a second source has been added to my logic grid, and I'm interested in the mixer tally only when not in emergency mode. I will click on the bottom line to create my dot there. On my panel, I'd like to be able to cut different sources into my emergency embedder. So I'm going to create a new page, and here I can select my 4 inputs to my emergency embedder. I'll be using crosspoints from the matrix and set them to be red when active. I'll also edit their bitmaps to be a little clearer. Now I'm going to add my emergency GPIO to this page too. In the properties window of this button, I'll select the control tab and select jump to this page when GPI becomes active. Remember that GPIO is an abbreviation for GPIO, so even if a function specifies GPI, it will still work when you use a GPIO. I can now cut different sources, and these will receive red tallies as you can see in the matrix and the corresponding GPIOs to the CCU. On the button that shows my emergency state, I will set the active color to red blinking, and I'm going to add a secondary function to restore normal working conditions once the button is held for longer than a second. To do this, I will go to the primary virtual matrix, select the GPI tab and drag the same node from the matrix onto the button, but before releasing, I will hold the control button so that this node is triggered as a secondary action when the button is held. Now we're out of emergency mode and normal operations can continue. Let's look at how GPI and GPIO can be applied for other functions. First, I'm going to save this file. I'll rename the existing file by adding other applications to the end of the existing file name. I'd like to start with audio follows video for audio mixes. We could use the drag and drop functions that we've seen so far, but that would mean that for every production we have to edit the configuration file. So I'm simply going to delete what I have just done. Rather than working in the configuration software, a much better approach is to adopt a panel-based workflow. When you do this, you can empower your operators to make their own decisions as to when they want to open faders and when not. I've given our panel its own place in the top left corner. For this purpose, we have a special button type called Assign Tally to GPIO. The icon of the tool to do this looks like a red light bulb and an arrow that points to a black dot. To use this, we need to have a panel that has our source signal paths and our destination GPIOs. To make testing a little easier, I'll add these to the panel and page where we did the emergency routing. I'll use a swap tool to move the escape button to the top row, freeing up 8 buttons in the bottom row. I will use the cameras as sources and I can drag these from my matrix. It will be a lot clearer if I shorten the names of the virtual signal paths. I'll do this in the signal path list. I'll simply call them CAM1 to CAM4. I can drag the AFV GPIOs from my GPIO list as targets. We're not routing, but simply assigning tally states to the GPIOs, so we need to change the button type of the GPIO to be the correct type. I can also select if I would like this GPIO to be triggered when the source signal gets a different color tally. I'll simply start with red tally. If I open my virtual panel, I can see that when I select an empty GPIO, it will blink, and now I can assign a source to it. I will do a reverse assign and then we can see the GPIOs will react in reverse. If the source gets a red tally, the corresponding GPIO will be set to true. Exactly the same workflow can be applied to create contact closures on a tailboard or wall box, to give tallies to crane operators for instance. To remove assigned signals, simply press the button twice. While we're here, notice the orange indication in the emergency GPIO. This is simply a warning that this GPIO has logic that triggers it, but at one stage a user action has overwritten this logic. This indication will stay here until next time you reload the configuration and doesn't necessarily indicate that something is wrong. Let's leave tally for now and look at some other uses for GPIs and GPIOs. There are endless possibilities. I'm renaming the configuration to joysticks because a nice example is joystick override for vision controllers. We would need incoming GPIs which would be generated by contact closures in joysticks or possibly through a protocol. As it is a little bit hard to show GPI, I've created GPIOs for joysticks too, and I've made the GPIO triggered by GPI, should the physical contact closures be available at a later stage. You may have noticed that the actual numbers of the GPI are not really important unless you'll be using them together with hardware. There are a number of recommendations, but anything is allowed really. The easiest way to get the joystick override to work would be to simply drag the joystick GPIs onto the nodes in the GPI tab of the master matrix, so that when they are triggered the crosspoints would be set. Note how the crosspoints that can be set by GPI are indicated by a red circle when you have the GPI tab activated. When you right-click on the crosspoint, you'll get a window that shows the details of the joystick that will set this crosspoint. While looking at this, note the little green dot on the crosspoint where the mixer program is routed to the emergency embedder. You can right-click here and you can see that this crosspoint triggers an event in GPIO 401, which was our emergency sensor. I can check if my overrides would work by pulsing the joysticks and watching the crosspoints in the matrix. Remember to activate the current tab to see this. Once again, we'd prefer flexibility, so I will delete these and choose to return to a panel-based workflow. I don't need the visual link right now, so I'll delete it and create space to add my joystick GPIOs. While we're here, let's look at how giving a GPI a short name would change the way that it's displayed on your buttons. You can edit the properties by using right-click and select Property. The preferred tool to use here would be a button type called Assign GPI to a switchable node. Hold down spacebar to change multiple buttons because your tool will be dropped every time you click otherwise. In order for this to be used, you need buttons for your potential sources as well as your destinations. I don't need the ISO tally button right now, so I'll delete it too using the blank tool. I'll use the cameras and monitors for sources and targets. I'm dragging these from the master matrix, but you can also use your signal path list if you'd like. I would also like to have the possibility to fall back to a reference source should the operator wish to do so I need a GPIO that will activate when no joystick is being pressed. That looks like a nice name for this GPIO too. I will drag my joystick GPIOs into this GPIO, and in my logic matrix I will set all of them to the not value. I will also have them all below one another, effectively saying that this GPIO will be true if joystick 1 and 2 and 3 and 4 are not being pressed. I will also add this GPIO to my panel. Now I can use my panel and at the same time test the functionality. As before, touching a button will make it blink. It is now registering the currently selected target, which I can change and select to be monitor 1, and it is also registering the next source button that will be pressed. I will do the same for the second, third and fourth buttons. For my no joystick is pressed, I will select program, which I still need to add somewhere on my panel so that when no joystick is being pressed, the monitor should return to the program source. If I select the none button twice, it will clear the assignment, and then you'll see that the signals latch at the last known source when nothing is being pressed. Once again we have the orange warnings, but this is just because of the testing of our functionality on the GPI window. As always, there are many ways to do this, and it's a personal choice really. This is just one way of doing it. Let's have a look at how GPIs interact with gadgets. I'm saving my configuration, and this time I'm adding the name gadgets. I need a device that will give us a gadget tree, so I'll connect to a vPro 8 simulator. You know the procedure, so let's speed it up. First, let's have a look at how the state of a GPIO can be set based on the values of gadget parameters. We don't need two windows of GPI anymore, and we don't need the panel or master window either. The most obvious way would be to use the audio level values of the outputs. The default value is 600. Let's say we would like to create an alarm if any values are set to be abnormally high. I'll create a new GPIO called audio alarm. Double-clicking on it will open the edit window and the properties window. I'll move these to the bottom left of the screen. I'll find the gadget parameters of the first four audio signals, and then I will drag these into this GPIO in the edit window. I'll set the condition to 601, and from the drop-down of each I will select if greater than or equals than 601. You'll also see different options which you can choose from. Now watch what happens to the GPIO if any of the values exceed 601. You could also do this for heat sensors or to create an alarm if power supply should fail, for instance. Remember that all VSM gear has temperature sensors that make their values available as gadget parameters, so you'd be able to use them as temperature sensors in your racks. If I right-click on this GPIO, I can select Create an Alarm from GPI GPIO. Now, if an alarm is triggered, it could be used in a panel if you have an alarm window, or it can send a message to your logging or data mining system. Next, let's do the opposite. I'd like to set the values of a parameter based on the status of a GPIO. I'm going to create two new GPIOs called HD and SD. I'm also going to bring back a panel so that we can press buttons and see a value rather than right-click. I will drag the newly created GPIOs to empty buttons on my panel. I'll use the panel function group elements to ensure that only one of my GPIOs can be activated by the panel at any given time. The panel will then automatically disable the other GPIO. Now, I will double-click on these GPIOs to open their properties window, and I will drag the output format parameter of output 1 of the vPro to both of these. In the properties window of the GPIO called SD, I will set the value to go to 625i50 when the condition is true. And in the properties of the HD, I will set the value to be 1080i50. Now watch what happens when I press the buttons. Finally, let's have a look at some other properties of GPIOs. I'll right-click on Physical GPI Out 1 and select the property. Over here you have some options, Persistent and Set to True on Startup. If you select Persistent, this means that the state of your GPIO will be saved within your VSM Studio server. After a restart of VSM, the GPIO will return in the state that it was last time the VSM system was shut down. Set to True on Startup means that every time VSM Studio is started, this GPIO will automatically be set. Only one of these options can be set at a time, and of course they're only relevant to GPIOs. So there you have it. I hope that you've learned something and that you enjoyed it. See you soon.
Welcome to Lawo Lounge, Lawo's weekly live program bringing you product tips, application insights, new product introductions, customer interviews, interactive Q&As, and more. Don't miss out this unique opportunity to stay connected.